I worked on fun stuff like a clip art website until I got fed up with IE problems and decided I'd come to the IE team to fix them. So I worked on IE7, I worked on networking, and I worked on a couple of trust-related features like SSL and so forth. My spare time, I've done a couple of things related to IE. I don't know if anybody's heard of Tamper IE or Fiddler. These are fairly popular add-ons for Internet Explorer, for penetration testing, and for performance, and for other tasks. As I mentioned previously, I'm a program manager for security for IE, and as a result, I get to hear all kinds of jokes about it. So now you can fill out your mythical creatures checklist and say that you have actually seen Internet Explorer Security PM in the wild. So, IE8, version 8, are we done yet? You know, there's not all that many products out there that are in their 8th version and, you know, still coming to conferences and talking about what's new and what's going on. And, you know, version 8, man, I'm tired. I don't know if you guys are tired. Are we done? And, you know, it's kind of interesting because as we were in the planning process for Internet Explorer 7, we figured, you know, we were behind. We had a lot to do. We had a lot of catch up. We did a lot of work. But, you know, we finished. We came out of IE7. We had a big plan. We did a lot of work. And as we went to plan IE8, it was kind of like, well, why is this so hard? You know, why aren't we done yet? And, you know, what's hard about browser security? And it turns out browser security is hard for a bunch of different reasons. But one of the reasons, basically, is just the simple complexity of the web browser system. The way that things plug into one another, the way that emergent behaviors arise when you put together things like extensions, arbitrary content coming off the web, all the different types of file parsers, HTML parsers, mobile code like JavaScript and extension languages. All this stuff combined together makes for an extremely complicated system where if you try and change any one thing, you're liable to break the entire system. And so complexity is one of the big challenges for the Internet Explorer team, not just for security, but also for making the functionality of the browser and the platform make sense. So looking at IE8, I actually joined the security team for IE8 roughly about a year and a half ago, just doing security instead of my old focus. And one of the big questions was, is there a shortcut? Is there something just blindingly obvious that we're missing? You know, maybe there's a way out of this problem. And so, you know, we took a look, and we took a naive look, and we said, hey, wait, we could block nearly 100% of exploits by just removing one of the components from the Internet Explorer system. You know, it'd be great, it'd be fantastic. People wouldn't worry about IE vulnerabilities anymore. Turns out it's kind of an important component in the system, and when you get rid of it, the browser's not really very interesting anymore. So that's not the simple solution. You know, unplugging the network cable, effective, but it's really never going to fly in the real world. So we take a look, okay, what else can we do? Is there something else that we can do? Some part of the system that we can shore up? Is there another part we can get rid of? Reduce attack surface? Yeah, get rid of the user. Get rid of the user, a lot of the problems, social engineering just completely goes away. And, you know, that's nice, but frankly, we not really have any users anymore, so that wouldn't be desirable. Then the last thing we could do is just redesign everything. And this is one of the things that's come to the forefront lately because there's lots of smart people that have started to look at the browser security problem and browser problems in general, and they say, I can do better. All we have to do is replace HTML, CSS, JavaScript, and get everybody to upgrade, and then we're good. You know, unplug the internet, do some upgrades, plug it all back in, and everything's better. You know, we'll put up some security, put lots of different locks, and you know, the user experience will never be the same, and you have to type a PIN anytime you go to a website, but you know, you're going to be safe. And of course, these types of things, not very common either. And so basically, if we get rid of the users, get rid of the network, or redesign everything, then we're good to go and we can go home. Well, all of these things just aren't going to fly. People won't, you know, they won't upgrade. They won't use the new version of the browser if we break everything or introduce major constraints that aren't there previously. And so we have to find a way to balance. And balance is going to be a key part of this talk because it turns out that security is easy. Balance is hard. The reason security is easy is because you can make any number of changes and dramatically reduce the attack surface of the browser, dramatically remove vulnerabilities, just make major changes. But if you do these in a way where people don't like the browser, where people don't use the browser, where the people don't upgrade the browser, then we haven't done anything at all. And Jeremiah Grossman this morning kind of set me up with this. He said that, you know, there's a conflict of browsers. Basically, they want market share. Well, Internet Explorer still has a pretty significant amount of market share. And our concern isn't about getting market share, right? We don't want to go steal Firefox's market share. What we want to steal is IE6's market share. There's a lot of people that didn't see the need to upgrade from IE6 to IE7. Why could that be? We worked really hard on it. We had tons of people working hard for years to build a browser. We released it. Many people eagerly upgraded, but for a sizable number of customers, they looked at it and said, yeah, why would they do that? And one of the primary reasons they would do that is compatibility. IE7 made some changes that impacted compatibility. Frankly, these changes were relatively minor compared to the stuff we've done in IE8. But they looked at it and they said, hey, wait, my website doesn't quite work right anymore. Maybe if I just ignore this IE7 thing will go away. Because that's what they'd gotten used to. The IE team not releasing browsers and old versions of the site work forever. Well, problem is you can only do that for so long before, basically the web collapses under its own weight. Things are outdated, things don't work properly anymore. So we need to come up with a solution moving forward that we can build a more secure version of the browser in a way that people will actually upgrade it and use it eagerly. So looking back, IE7 significantly reduced the attack surface of the browser and the local machine. And so we did a good job there of protecting the machine, the classic thing that bad guys wanted. Back in the mid-90s, I was telling Jeremiah earlier, in the threat model for iframes for the first time, one of the people brought up what became clickjacking. He said, hey, you could put a button from some other site and get people to click it and they would never know. And they said, you don't even get root from that. Why would you bother? Because back in the mid-90s, it didn't matter. The websites out there didn't have interesting content. People didn't have passwords on them that were meaningful or useful for stealing money. And so it just didn't matter. Well, IE8, times are different. 2008, it's 10, 15 years. Browser's getting up there. And the attackers are getting ever more clever. There's social engineering. There's attacks against add-ons. The web application attacks are becoming alphabet soup. CSRF, clickjacking, XSS, HTTP response splitting. All of these things. There's conferences, there's talks. Hey, there's a new way to do X or Y. And all of these, generally there's something in the browser could be doing to help mitigate this. So browsers, go drop everything and do it. And of course, the other problem is that, basically there's no limit to the number of attackers. At the time we wrote this originally, the next generation of attackers is coming out of grade school. It was kind of tongue-in-cheek, and it's kind of true. We actually had some guys who were pen testing for the IE team who were, well, let's just say they weren't legally old enough to be employed without having their parents fly out with them to work for to come out with them to Microsoft during their internships. And so basically, there's lots of smart kids, and the web is still so dynamic that someone who's got unique ideas about how to combine things together can come together and put together attacks. And then the last problem, the reason that this is the most persistent problem is it turns out that crime does pay. And people are making significant money doing bad things to other users on the web. And that's an economic force that drives the innovation of the bad guys trying to attack the user. So what's next? Well, let me just give you a quick little ramp up on IE8. So IE8, we shipped our beta 1 for developers in March. And that was basically around getting people used to the new standards compliance work that we've done, work in the JavaScript engine, and so forth. It was pretty rough around the edges, and most of the normal end users who installed it said, wow, this is pretty rough, and they uninstalled it. Beta 2 came out in August. Pretty good reception, got millions of people using it around the world. Still got some rough edges, but we're definitely moving toward the final version, the things that people will see. And so I've got a daily build on my laptop. If I do a demo later, hopefully it will be nice and robust for us. But we're going to release IE8 when it's done. And I know that that annoys a lot of people, but the reality is that we really have to come together on the final set of functionality that is the proper balance for our users. And so people come to me and they say, hey, what are you doing about clickjacking? Well, clickjacking really only sort of hit the media spotlight about a month ago. In Internet Explorer 8, we're pretty much done. And so people are saying, well, you can't ship unless you do something. And other people are saying, well, you've got all this goodness. Get it out there as soon as possible because we want to get we only want to do one migration. We want to do IE6, and we want to jump straight to IE8 right away. And so doing that balance, figuring out what the right ship date is, the right feature set, it's always very complicated. But we're close. And so Internet Explorer 8 is going to be available on Windows XP, Windows 2003, Vista, and it'll be the browser version of Internet Explorer that ships with Windows 7 when Windows 7 is released. So what's our vision? You know, we looked at a lot of problems. Vision, got to figure out which direction we want to go. The direction we want to go, IE8 is the most secure browser by default. Now in IE7, we added security feature after security feature. Protected mode, ActiveX opt-in, the extended validation certificates, international domain name lockdown. We had tons of features. Things you put on the box and put a check mark, and marketing was happy because it was really easy to talk about them. And those are security features. And we've done a few security features for Internet Explorer 8, and in the slides we'll get into what those are. The next part, though, is secure features. And this is the key thing for us as the web platform gains in power. We have to make sure that as we add new features to enable new scenarios, that we do so securely, and we actually reduce rather than increase the attack surface of the browser. Because right now, the browsers are so complicated that if you add attack surface to them, you're soon going to end up with just a completely exploitable system where you spend all of your time issuing patches. And we've got to get out of the business of having one-off patches every month of, oh, just found a new vulnerability in new feature X, new feature Y. And so attack surface reduction and defense in depth have been key principles throughout the Internet Explorer 8 design. And then the last thing, as I mentioned before, is finding that proper balance. If people don't upgrade, then everything we've done for security is for naught. And so we have to make sure that we're offering them compelling features that aren't security related. 5 times faster JavaScript engine, standards compliant layout, new features like accelerators and web slices that get people excited about using the browser. So we've got to have a good balance, and security is an important part of that, but it's not the only part. This is the state of the world after IE7. This is the CVE distribution report that we looked at when we were trying to figure out, okay, well, where do we focus our security dollar investments? And unfortunately, it's a little small on the screen, but the two things in red are cross-site scripting and buffer overflows. The two blue ones in the middle are SQL injection attacks and PHP remote file inclusions. So basically, the top 3 things are web server-side vulnerabilities, places where web code has a vulnerability. And the buffer overflows, of course, is something on the browser side. So we said, okay, well, these 4 top pillars that tower over everything, we need an answer for these 4 pillars. It turns out for PHP remote file include and SQL injection, there's not a lot you can do from the browser side of things. And the reason you can't do a lot from the browser side of things is I can just telnet to your web server and attack you that way. And so it's not very interesting from the browser perspective. On the other hand, cross-site scripting. You're misusing somebody's browser to attack a web service. You're using their browser. We own the browser. We can fix the browser. So we made investments in cross-site scripting protections for IE8. And then lastly, the buffer overflows. Obviously, it's been a big area of focus over time, and we've done a lot of defense in depth, and we've done yet more in Internet Explorer 8. So when we think about the investments we make, we have a high-level security guarantee, the thing that we are trying to achieve in the browser, and that's nothing bad happens. And of course, it's comically just broad. It's not specific enough. So we say, okay, well, what does that mean? Well, nothing bad happens to your machine. Nothing bad happens to you, your finances, your privacy. And nothing bad happens to the web services that are used by Internet Explorer. So we broke down into browser add-on vulnerabilities, the things that we need to ensure that the other guarantees are met. You know, if there's a buffer overflow in IE that allows remote code execution, it doesn't matter about the other features because the bad guy's running code. At the same time, social engineering. We need to help protect users from themselves, from making bad decisions. And then lastly, web application vulnerabilities. We need to see what we can do to shore up defenses automatically for web applications, and also provide a set of opt-in things that ensure compatibility and allow web applications to be built more securely. Starting with browser add-on vulnerabilities. This chart may be familiar, maybe not. This is basically ActiveX. Everybody looks at Internet Explorer and they say, geez, get rid of ActiveX. It's terrible, it's horrible. It's the thing that's weighing you down. And to some extent, that's true. ActiveX has been a huge source of problems. The problem with getting rid of ActiveX is people don't understand what it actually means. YouTube doesn't work. Okay, well, for some people that's fine. For other people, that's a deal breaker. You know, basically anything dependent on Flash, QuickTime, Real Player, Windows Media, none of these things work anymore, right? ActiveX is an example of a plugin model. It was a plugin model designed, back in the mid-90s, and we've done a ton of work to shore it up. ActiveX today looks nothing like it looked back then. We've added a lot of restrictions. We've made a lot of tweaks to ensure that ActiveX, the vector, is less appealing now, and we'll get into what those are. So the thing that we've done over the years is we've increased the length of what we call the gauntlet for ActiveX controls. So originally the gauntlet just consisted of, you'd ask the control, hey, are you safe to run in the web? And the control would come back and say, I sure am. And a lot of times this was because the control was intended for design in the web, running on the web. But sometimes it was just because that's how a popular framework like Borland Delphi would automatically create ActiveX controls. And so people would build ActiveX controls with this idea that, oh, we're just going to use it within our application and so forth. And then suddenly you find out that the money ActiveX control was marked safe for scripting and could be called from Internet Explorer. And that was a security conference like 13 years ago or something. And that was the big O day of the day. So something else went on. We introduced a new measure to the gauntlet, and that's kill bits. Basically, the ability to have a list of ActiveX controls that is rolled out through central update mechanisms saying, this control can't be run in the browser. And so basically, if a vendor finds a vulnerability in their ActiveX control that they need to ensure that that control doesn't run within the browser, they contact secure@microsoft.com, and they get that control flagged as kill bitted. That control will no longer load. Then we've got our traditional, hey, are you safe to run in the browser, iObject safety, are you safe for initialization? And essentially, we've improved our guidance there. We've shored up our toolkits a bit. But still, we're relying on the control to tell us whether or not it should be allowed in the browser. Internet Explorer 7 introduced one of the most unheralded but most important attack surface reductions against the IE stack called ActiveX opt-in. What ActiveX opt-in did was it took, by default, the majority of ActiveX controls off the attack surface of the browser. By default, any ActiveX control that just happened to be on your system, not installed through the browser, became unavailable. So you had to use an information bar to allow that control to be run. And so what this did is it prevented controls that just were vulnerable, but never intended for use in the browser, the SharePoint log management control, things like that, from running automatically. And so in IE6, you could visit a website, and it would do a drive-by against you. Basically, it would go have this iframe that has 50 different ActiveX control exploits, and would try and load them all and try and take over your machine. When you visit that site in IE7, usually what you'd get is basically an information bar saying, Internet Explorer blocks some controls in this site. And you click the drop-down to see what it is, and it's like 40 long. And you're like, wow, I don't understand why this thing wants to use the WinZip ActiveX control. So we made a major change there. We took tons of stuff off the attack surface. But it wasn't enough. And the reason it wasn't enough is because there's some ActiveX controls that are intended for use in the web, absolutely, unconditionally. But they don't need to be used everywhere. So a prime example of this is the ActiveX control used for media playback at one of the major 3 web portals. They've got their own music jukebox, right? And they have an ActiveX control that plays music. And it's fine, it's wonderful, except, oops, they wrote it, there's buffer overflow, and you can actually take people's computers over with this. Okay, well, if it only ran on their site, that would be okay, because they're not going to exploit the vulnerability. But other people can. And so for a long time, we've had a template, what's called the site lock template, that would allow a vendor to make their ActiveX control only run on the website from which it came. But it turns out that most people aren't using this. Partly it's an issue of it hasn't been evangelized enough. Partly it's an issue of they just haven't gotten around to it. They don't have the source anymore, and so forth. Well, what we've done in IE8 is we looked at what SiteLock did in terms of attack surface, and we said, that's so good, we have to give users this feature by default. So Internet Explorer 8, by default, makes ActiveX controls per site. When you go to a website and it installs an ActiveX control, by default, that ActiveX control is only available from the site that gave it to you. And so what this ensures is, in the case of that music player vulnerability and so forth, that control just isn't available on your attack surface to attack you. You can manage this yourself. You can opt that control in for other sites if you want, and you can take it out. So if there's a really nice plugin that's critical to lots of web functionality, but it's misused by advertisers all the time, boy, that's annoying. You can make it run from nowhere by default and then manually approve. And so you can reduce your own attack surface as an end user by making controls only useful from the sites that you trust and you allow to run code. And so this gauntlet has only gotten longer. Now, we looked at some other things. One of the other things that we looked at is, what can we do as defense in depth? We know there's going to be vulnerable controls. We know there's going to be vulnerable controls that were just written for the web. Everybody expects them to run on the web, but oops, there's a memory vulnerability. So what did we do? Well, Windows Vista was the first OS to really push out one of our significant things around data execution prevention. So data execution prevention is a feature of modern processors and the operating system to keep track of which pages in memory are meant to be executable and which pages are meant to be just data. And if the processor encounters a page that's marked to be just data, your stack or your heap or whatnot, and it's about to execute code from it, it says, wait a minute, this page wasn't marked as executable. So rather than running that shell code, that exploit code that provides access to your computer, the operating system just terminates the process. So this feature became available in Vista on IE7, and it would have been one of the most valuable things we could have done to reduce attack surface. There was a problem. Almost all ActiveX controls at the time were written in ATL in versions that came with Visual Studio 2003 and earlier. ATL was not compatible with data execution prevention. So had we turned this on in IE7 on Windows Vista, we would have broken pretty much every ActiveX control that was out there. We thought about it pretty hard anyway, because the attack surface reduction was huge. But ultimately, it was decided that no, people won't install a browser if it doesn't work on most of the sites they care about. We can't do that. Well, time has changed, and fortunately, the Windows team, recognizing the importance of getting data execution prevention available everywhere, made changes to the latest service packs and the latest versions of Windows to provide an API called setProcessDepPolicy. And basically what setProcessDepPolicy does is it allows you to opt into dep while making sure ATL stuff still works. And so by default, Internet Explorer 8 on Windows Vista SP1, Windows Server 2008, Windows XP SP3, and so on, the latest versions of all the service packs will turn data execution prevention on by default. Now this is great because it shields the add-on vulnerabilities as well as Internet Explorer memory-related vulnerabilities as well. So if there's a parser bug or an HTTP stack bug or an ActiveX control memory-related vulnerability, data execution prevention can help mitigate that. Now there's a bunch of other memory stuff you might have heard about for Vista. You've got ASLR, SafeSEH, GS, and so forth. Internet Explorer basically opts into all of the defenses available. And we've gone out to the partners, major ActiveX control vendors, and we've worked with them to get the latest versions of their controls compiled with these options too, all to mitigate this code execution possibility. The last thing I'll mention on this slide is, oh wow, process crashed. It's a good crash because shellcode didn't run, but it's pretty annoying. Internet Explorer 8 introduces a new architecture called loosely coupled IE. Loosely coupled IE basically ensures that the browser frame and the browser tabs run in separate independent processes, such that if the browser tab processes crash, they can either be recovered automatically, or in the case of a dep crash, we don't want to give the bad guy another shot, so we just show the page shown here, basically explaining to the user that there's been an incompatibility discovered and so forth, and giving them the option to either try again if it's a site they trust, or get out of there if they were just kind of randomly surfing around. And so loosely coupled IE has a bunch of benefits that percolate throughout the system. Of crashes in Internet Explorer, something like 70% are caused by third-party code. If you run IE without add-ons, it's usually way faster and way more stable. So part of our job is to get add-ons written better, but part of our job is also to be more robust in recovering in the event of a crash. Quiz for the audience. What's the safest block of C++ code? One that's never written, obviously. So this is a principle, right? You make things faster by not running code. You can also make things more secure by not running code. Internet Explorer 8 includes a bunch of new non-binary extensibility. Traditional security guys look at me and they're like, that's not security. Well, it is actually, because if you don't have either unskilled or hurried or otherwise people who are generating code that's not very well written, and you give them safer alternatives that allow them to achieve their goals faster, more reliably, and more securely, they'll take them. And so IE8 includes accelerators, web slices, visual search suggestions, and a bunch of new goodies for AJAX. And so we're going to briefly fly through them. Accelerators. Basically, accelerators are an XML manifest that you can put on your site that users can install, and then your service becomes available from the Internet Explorer context menu. So you can do things like look up definitions, do translations, map, all of the things that a lot of the websites are trying to do today. You can add them to the aggregation sites like Dig and so forth. And now you don't have to have a browser plugin that's slowing up your startup performance and otherwise impairing your ability. You're able to do things much more quickly. Web slices, the ability to put some of the web content into the frame. So rather than having some sidebar gadget or some standalone browser toolbar that tells you what a stock price is or the weather is or whatnot, basically, again, XML manifest pointing to, it's done through the RSS feed system actually, but most of the implementation details are hidden from you, the programmer. And basically all you do is you mark up parts of your site, a slice if you will, and the user can add that slice to their favorites bar. And so they get an updating piece of content that's available from their favorites bar, no add-on. When they want to get rid of it, they just right-click and choose delete. But the performance is much better, and of course the security much better. We've improved our manage add-ons experience in IE8. Basically, we made the dialog resizable, woohoo. We did a bunch of stuff around enabling the user to copy the data out of this. So if your browser's crashing all the time, you can just go in here, select all, copy to a spreadsheet, and mail it off to somebody to analyze it. So there's some websites on the web that'll do that and say, oh, this is the plugin that's known to crash all the time. We also did a toolbar advisor in IE8. So when we load up and we determine that you've got a toolbar that's going to cause a compatibility or security problem, we notify you and allow you to disable it. And then also the other thing this thing does is it shows you the load time of add-ons. So if you say, geez, IE is super duper slow, what's going on? You're likely to get asked, hey, go up into manage add-ons and see how long add-ons are taking. And sometimes you'll see an add-on that's taking 4 seconds every time you create a tab. And you can say, it's not really that valuable. I'm going to get rid of that one. Protected mode. Protected mode was a feature for Internet Explorer 7. It's available again in Internet Explorer 8. Protected mode is kind of the ultimate backstop against these problems where if bad guys get code running on your machine, that code runs with low integrity. It's essentially a sandbox that sits around the browser and ensures that you can't write into critical file system places like the startup folders, you can't install programs, and so forth. One of the nice things about IE's loosely coupled IE architecture is previously you couldn't have a window that contained content from the internet and content from your intranet at the same time, because in Internet Explorer 7, each window was its own process, and all the tabs in that window ran in the same process, and a process can only have one integrity level. Well, with IE8, now you can have tabs running with different integrity levels. So the user experience annoyance that was introduced in IE7 has been mitigated. We've done some other stuff. We've moved the intranet zone to medium integrity, so out of protected mode by default. This is a performance improvement. If for some reason you don't trust your local intranet, you can actually go back and put it the way that it was before. But the primary reason that the intranet was running in low before was the user experience issues. Made some minor API improvements, so if you're a plugin, you can interact better with protected mode. One of the other things we saw over the past 2 years or so is people misusing application protocols. So an application protocol, in this case, I think it's the OneNote protocol. Application protocols are a way for a website to pass data to a program running on your computer. Last summer, you might have heard about there was an application protocol vulnerability within Firefox. And so basically, browse to a site in Internet Explorer, and it would launch Firefox and go abuse Firefox's vulnerability. And the Firefox guys, they fixed their vulnerability. It turns out that uncovered a whole chain of vulnerabilities elsewhere in Windows. But one of the problems was Internet Explorer wouldn't notify the user when launching an app protocol. So an ActiveX control, you get an information bar, tons of security around it. But if you had an app protocol installed, basically, bad guy knows about it, bang, you're owned. And so what we did with app protocols is we introduced the prompt. Now, we hate prompts. Prompts suck. Users don't like prompts. The reason that we had to have a prompt, essentially, is back to that compatibility and balance. If we just disabled app protocols, well, people wouldn't upgrade because their app protocols didn't work. Turns out these are used more broadly than most people think. But at the same time, there's really no way to programmatically, automatically determine whether anything is malicious or not. So sometimes we have to delegate the trust decision to the user, even though we hate it. Moving nicely into the next topic, social engineering. Delegating trust to the user is a problem. Humans aren't wired for the kind of trust decisions that they're being asked to make today. Trust decision here, do I get in the boat? Pretty easy, no. No, it's a little more subtle. Do I get in the water? No, I don't think so. basically, it's relatively easy within nature to see what the aggressors are, the attackers are, and of course they're always working harder and harder to camouflage themselves. Unfortunately, in a digital world, if you're a bad guy, it's really easy to camouflage yourself as a legitimate thing. So we've done some work in IE7. We introduced a phishing filter in IE7. We've done some more work in IE8. One of the things we did in IE8 is domain highlighting. Now, for a certain class of users, this is helpful because they can more easily determine what website they're on. So essentially what we do is we highlight the host name of the site you're on. And so in the case of that attack down there that hasn't yet been blocked by the phishing filter, you can pretty easily see that even though there's paypal.com within the address bar, there's also fisher.org, and fisher.org is the part that's in black. So this kind of stuff seems pretty obvious, but it turns out that for some users, this isn't going to help them at all either. And we found this out. We did a Living with Vista study. We went out to a user's family, and we talked to them, and we saw how they used the browser. And we noticed what they did is every time they booted the browser, they'd go to a web search engine, and in the search box, they'd type the URL of where they were going to go, and then they'd hit go, and then they'd click on the first link. And we said, well, why do you do that? And they said, because that's how we surf the internet. And we said, well, there's this box up here at the top. It's called the address bar. Type the URLs in there, and you just go straight there. They said, oh, we never noticed that before. Well, first, we were kind of shocked, but we actually did some studies and found, some users don't actually notice the address bar at all. But furthermore, that creates a problem, right? If the user doesn't even know to look at the address, there's no hope of doing anything in the address bar that's going to help the user. So we said, OK, we obviously need to continue our investments. Now, we also did EV certificates. Lights up the address bar in green. This has been ported into other popular browsers. I think there's like 7,000 now extended validation certificates issued to date. But again, you've got the problem of non-technical user. Look for the green address bar is easier than look for the domain name that you trust. But still, it's not as easy as we would like. Smart Screen. So Smart Screen is the evolution of the Internet Explorer 7 phishing filter. The phishing filter was a URL reputation-based system that would flag known malicious phishing sites that were trying to harvest your credentials. Well, it turns out that harvesting your credentials is only half the thing that malicious sites would try and do. The other thing they would try and do is try to get you to install software that would otherwise imperil your computer. And so Internet Explorer Smart Screen introduces a new URL reputation-based anti-malware system that works in concert with things like Defender, OneCare, your antivirus, Spybot, et cetera, to help protect you from malicious software, but it's URL reputation-based. And we'll get to why that's important in a minute. The other thing that we've done is we've introduced some new telemetry options out of the Smart Screen filter to make sure that we can block phishing sites more quickly. Because quickness is everything when it comes to phishing. Average phishing sites are live less than 2 days. The sooner you get those sites blocked, the more customers you save. We've also introduced group policy control that puts admins in control of the policy. So they can actually say for their organization, we actually trust the Smart Screen filter. We don't want to allow the user the ability to override warnings because users will shoot themselves in the foot given the option. Quick little sidebar here, lies, damn lies, and benchmarks. One of the things that we see happen a lot is people do benchmarking studies. They say, oh, well, we compared the 5 following phishing filters, and we found that N was the most effective and X was the least effective, and here's the number of sites they saw and the number of sites they didn't see. Metrics are really hard. You can look to the antivirus industry for this. What's the most effective AV package? Well, turns out what you're measuring. What's the most effective phishing package? Turns out what you're measuring. You've got to look very closely at the methodology for these studies to see what they protect against. A lot of the studies, basically what they'll do is they'll go out and they've basically got a harvest mailbox where they harvest fish emailed to them. And they take that as their input set, and then they go run it through all the phishing filters, and they see how each one did. The problem is phishing has become a lot more broad than that over the past couple of years. We're seeing things like phishing attacks being spread by messenger clients. We've seen things like phishing attacks being spread by social networks. That's the one that's going up a ton. And so as these vectors change, the methodology becomes critically important. So how do we measure? We essentially measure based on how many attempted navigations to malicious sites did we block a week. Now, it varies actually pretty wildly depending on what campaigns are in the wild. But so far, the IE7 phishing filter blocks more than 1 million navigations to malicious sites per week. And so that's a pretty good number. We think the number is going to go up quite a bit with IE8 because it turns out malware and malicious downloads are way more prevalent than anyone realized. The other thing we did is we improved the UI. We're trying to get to that alligator effect where you look at the boat full of alligators and you say, you know what, I'm really not going to go there. So this error page used to intentionally look a lot like the IE connection pages. You know, it was all the same designer. It just kind of had a subtle red tint to it. We've made it way more bold. We've simplified the advice to users. We've given them something else to do. Go back to your home page instead for the users who don't really get browsing. They just like to click on stuff. And then for the IT admin, we've given them the ability to actually remove that disregard and continue link. So you can basically say, you know what? It's my network. You're on your work machine. You can't install malware even if you want to. And so this is one of the top things that IT admins have asked for. I've got a quick screenshot of telemetry. One of the things we can do is if we see suspicious things in the system, new website comes out of nowhere, tons of new users hitting it, there's things heuristically that are fishy about it, we can actually ask a certain subset of users, hey, is this really the site you thought it was? Users can vote. That vote goes into the grading system, and then we can prioritize the work of the human graders so we can get those phishing sites taken down faster. Now, social engineering. Downloads can be useful, is what this dialogue shows. You know? Wow, that's really great advice. Kind of reminds me of this thing I saw on a beach in Hawaii. Basically, on one side it says, danger, no swimming. And on the other side it says, if in doubt, don't go out. Seems kind of conflicting advice. Go out, but don't swim. So it's a case where, you know, they don't know. You know, maybe you're an expert, you know, Olympic swimmer, and you know you're fine. But on the other hand, you're probably not. So let's tell you not to go out. So we kind of have that conflicting thing in the download dialogue of, you know, downloads can be useful, but they can also destroy your computer. So what we've done, you know, and this was one of the warnings I thought was more effective. Basically, they just have a running tally of the number of people who died. And you know, in some cases that's pretty easy because you know you say, wow, you know, when I walked by that sign, the only thing I thought was I don't want to be the next scratch on that sign. And so, you know, what can we do? And again, basically, we can make this much, much bolder. And so in IE8, when you visit a site that's known to distribute malware and you attempt to do a download, the download dialog is completely interrupted. We say, hey, this download's been reported as unsafe. The default is that the download is aborted. We do this reputation check both for file downloads and for ActiveX installation. So if there's a malicious ActiveX control out there, we can do the same thing. And then again, we have group policy there that allows to take the decision out of the hands of the end user and put the IT admin in charge. And that was one of the top things that they requested after IE7 is, hey, I don't ever want my user to make a security decision. I want to make the security decision for them. And so using group policy as an IT administrator, you can turn off the user's ability to override things like certificate errors. You can block insecure content. You can turn on the smart screen filter and not allow the user to override its blocks. And you can regulate which ActiveX controls are allowed to run and where. And so altogether, there's 1,300 group policies that put you as an IT administrator in charge of what your users can do. Now lastly, and in some respects the most interesting stuff, the web app vulnerabilities. You know, Jeremiah's talk this morning, super popular. It's an awesome exploit. You know, there's so many different ways that things come together and put the user at risk. And as more and more interesting content moves to the internet, the incentive for attackers to find these things is ever greater. So this is a pivot of one of the slides from the White Hat Security Report. Basically, likelihood of a given web application containing a given vulnerability. XSS, again, off the charts. So XSS, what can you do with it? Who cares? You know, some people don't understand XSS. XSS is the new buffer overflow, Brian Sullivan likes to say. And the reason he says that is not because they have much in common with buffer overflows in terms of the exploit itself, but rather because of what you can do with it. As more and more applications move to the web, XSS is how you get arbitrary code execution in someone else's web application. Once you have arbitrary code execution inside someone else's web application, you can do all kinds of badness. So XSS threats are a web-sized vulnerability. But because the web vulnerability has to be exploited through the browser in order for it to be useful, we in the browser have the opportunity to do something about it. The way the XSS filter works, this flowchart's a little too small to see, but basically what we do is we look to see whether a navigation is going cross-domain. If a navigation is going cross-domain, we look to see what's going out with the navigation. Is there script in the URL or in the post body? Simple enough. One approach would be, okay, if so, stop here. Problem is it doesn't work. It kind of breaks the internet when you do that. Because it turns out that lots of things pass script, or things that look exactly like script, in innocuous ways. They either pass it to themselves, or maybe it's a submit a script database where you go share JavaScript source code with other people. If you just prevent that outbound post, well, kind of broke that site completely. People will say, oh, don't upgrade to IE8, it breaks our site. What can we do? So rather than blocking it completely, what we do is we generate a signature out of it. We heuristically look for the things that could be executable script, and we take note of them. And then what we do is we actually wait for the reflection. We wait for the server to send back the response page, and we look to see in the response page, was that script reflected back to the user in a way that it's going to execute? And if so, we modify it. Specifically, we neuter characters out of it. So in the case here, basically, we've got this hacker site demo there, and we generated a script signature saying, hey, if you see an outbound GET request or POST request that contains script source equals, then generate a signature off of that and look for that response in the body. And if it's found, then sanitize it so that it doesn't execute. Now the key point in here is we sanitize it so it doesn't execute. We don't throw the user to an error page. We don't ask them to decide. We just do it, and we do it in a way that most likely the page won't break. We actually had a false positive. We had a bug in beta 2 where if you go to Amazon and you do one-click checkout, it turns out that goes cross-domain. We sanitize something in a way that's not supposed to, because it wasn't really going cross-domain. It was just crossing protocols. And so false positive, terrible. Why aren't people saying don't use IE8 beta? Because it turns out it was entirely innocuous. So we sanitized part of the response page. That part of the page wasn't ever used by the customer in any meaningful way. So they'd get this gold bar saying, hey, we saw some possible cross-site scripting and we changed it. But for the normal user, they don't care. Nothing has changed about their web experience. We've just presented the possibility of code execution. So we continue to tune the heuristics. The false positive rate on this thing is just tiny. And so that's why we're proud of the XSS filter, because we can turn it on by default. There's lots of security add-ons for different browsers that allow you to mitigate this type of thing, sort of, but you get lots of prompts. You have to make decisions. Your websites may not work anymore. This is something that's safe enough that we can turn on for the web by default. Done a bunch of other work to help reduce attack surface against other types of cross-site scripting attacks. Most of this is the technical geeky stuff that the guys writing cross-site scripting filters in the server side of content get excited about. Turned off the US ASCII code page. We don't sniff UTF-7. We don't do char set inheritance across iframes that are cross-domain. We fix code page related bugs. CSS expressions are disabled in IE8 standards mode, big attack surface reduction. And we've introduced a bunch of new AJAX features that enable more secure mashups. We've added new native JSON support. So native JSON support is great because what you can do, one of the dominant ways of exchanging data on the web today is in JavaScript object notation format. Basically, a JavaScript object you can pretty easily serialize into a string. The problem is people use this to pass data between applications cross-domain. The primary way that people revive these strings back into JavaScript is by calling the eval function. What happens if you call eval on executable code? It runs. The native JSON stuff enables us to parse things directly into JavaScript objects while dropping all of the executable functionality out of them. Now you can exchange a string of JavaScript object notation cross-domain and then revive it without the possibility of that other domain getting code to run in your domain. Another thing we've done on top of that is what's called two-static HTML. Two-static HTML uses the Microsoft anti-cross-site scripting library, which used to only be available on the server side. We've moved it to the client, so it's a function on the window. So now you can have an AJAX application where you pass it a dangerous string of content. In this case, it's supposed to be some simple HTML, but there's a script block embedded in it. When you run it through the two-static HTML function, we strip out the scripts, and we strip out dangerous CSS styles. So now you can have an AJAX application that doesn't have to hit the server to get these protections. This helps mitigate against other types of cross-site scripting attacks, the type 0 attacks and the type 2 attacks. Now, passing strings between domains. The primary way to communicate between domains today in mashups is, hey, just put my script source into your page. You want my ad on your page, just do script source equals bigadvertiser.com whack pagead2.js. Well, that gives that big advertiser the ability to run arbitrary JavaScript within your page. We've introduced new ways for sites that want to communicate safely. We've introduced cross-document messaging. Cross-document messaging is the post message feature of HTML5. It allows you to pass strings between frames in ways where it's more secure because both the origin and the destination are checked against what's expected. You can further secure cross-document messaging by passing the output through either the JSON parsing functions or to static HTML. So basically, you can go ask this other security principal, hey, give me a string of something that you want, and then you can sanitize it and use it more safely. We've also introduced the XDomain request object. The XDomain request object is competitive to the cross-site XML HTTP proposal that's before the HTML5 working group today. The reason we did XDomain request is we looked at cross-site XML HTTP request. We looked at the history of building cross-site communication with arbitrary HTTP headers. And we said that attack surface is insane. You're going to spend the next 5 to 10 years patching holes in it. Ultimately, sites don't need that level of functionality. If we provide a simple way to do an HTTP request against another site in such a way that we can provably show that it doesn't increase the attack surface of the browser, we've done a great thing. That's what XDomain request is. We put it out to the standards bodies, and we said, we think you should standardize on this instead. Done some other work around getting code not to execute. MIME sniffing. Anybody in the room know what MIME sniffing is? OK. Different audience, I guess. Good. We made it better. File upload control. The file upload control has historically been a huge source of security vulnerabilities. Basically, for the last 15 years, the history of browsers, essentially, the file upload control has been always of interest to attackers because they found all sorts of tricks to get it to steal files off your local file system. So we made some changes here in IE8 to reduce that attack surface. Puts us in line with the other browsers and helps ensure that files can't be stolen when you just go visit a website. Now, got 13 minutes left. I've been talking nonstop for quite a while. Privacy is a really interesting thing. And the reason I want to go through privacy super quickly is because it turns out people care a lot about privacy. When we were planning IE8, we said, what are your top concerns? And privacy was actually pretty high. Now, it's very interesting because there's two types of privacy we found. There's privacy, the over-the-shoulder shared PC privacy. I don't want people in my house to know what I visit. And then there's also aggregator privacy. I don't want some big major advertiser with their content and tons of web pages across the internet tracking me. I don't want a beacon to go out and notify my social network every time I go buy something and potentially let my friends know what their birthday gifts are. So there's two types of privacy. And in recognition of that, we've got a couple of features. The first thing we did, holdover from IE7, essentially the post-facto privacy. I've done some surfing, sensitive nature, did some banking, did some downloads. I don't want that content to linger around. Maybe I'm on a kiosk machine, maybe I'm on a friend's machine. We've beefed up the delete browsing history function with a new option to preserve favorite website data. So what this means is you can easily check an option where the sites that you care about, your favorites, we maintain state, and everything else gets blown away. And so if you're concerned, some random website search engine is tracking me or whatnot, you can just make sure that you don't have it as a favorite, and then you can set the option to delete browser history every time you exit and preserve your favorites. And in that way, you've got control over the profile that's built up of you on your machine. Now, we've got two new features that are under the in-private brand. One is called in-private browsing, one's called in-private blocking. In-private browsing is the shared PC case. I want to go do some browsing off the record. Pretty meaningful for me. I just got engaged. Did some engagement ring shopping. My girlfriend, now fiance, shares my PC. I don't want her to know that I'm looking at rings, and I certainly don't want her to see which rings I'm looking at. It's supposed to be a surprise. It's pretty easy now. File, new private browsing session, good to go. In-private blocking we'll get to in just a second. In-private browsing, basically a screenshot here, pretty easy to launch, iexplore.exe-private. In-private browsing turns on. Your browser doesn't keep track of cookies anymore. All permanent cookies are downgraded to session cookies. Your temporary files that are created during that session are removed when that session is closed. We don't keep track of history. And one of the important things is we don't actually keep track of visited links. So in Jeremiah's talk this morning, he was talking about the CSS history attack, where you can just put a ton of links in a page and then use CSS to figure out, has the user been there? Or you can use JavaScript to see whether or not the color of the link is such, has the user been there? That attack doesn't work in private mode because in private mode, we don't keep track of visited links. So this is great either way. If you go to bad sites in private, they can't see anything about your normal browsing sessions because visited links are disabled. Similarly, if you visit your banking sites and so forth in private, and then you visit the untrustworthy sites in normal IE, they can't get the session data from the in private instance because it wasn't created. And so there's a mitigation against that attack. There's a bunch of attacks that allow this type of thing. The browser is a very intricate platform, but here's one feature that chips away at that. Next problem we looked at is the aggregation problem. And the reason aggregation is interesting is because it's a problem a lot of people don't really realize they have, but when they find out, they get very uncomfortable. So here's just a normal user. He visits a site, and that site actually introduces some third-party content. Maybe it's an ad, maybe it's an Ajax library, maybe it's just an icon saying, hey, add me to your visited links or your favorite links, dig like, things like that. And he says, okay, whatever. He doesn't understand. He just sees one URL in the address bar. He doesn't see the third-party content coming across the wire. There's a problem, though, because if he goes to another site, that other site may have the same relationship. In fact, there may be a lot of sites that have that relationship. Now, the problem is the user doesn't necessarily see this third-party relationship. And in fact, they don't have any trust relationship at all with this third party. But this third party is able to see their use of the internet across all the sites that they care about. So they can put together a profile. They can say, well, he's a male. We think he's between 25 and 35. He likes sports. They can put together a massive amount of data. And you don't even need cookies for this. P3P doesn't help you here because it turns out there's so many different ways of communicating unique identifiers that the network communication itself is dangerous. And so IE8's in private mode introduces the in-private blocking feature, where you can either have Internet Explorer automatically determine where these third-party trackers are and let you control whether or not they're hit, or you can subscribe to an RSS feed. So there's going to be privacy-conscious organizations that put out lists of the tracker sites. And you can subscribe to a block list and actually get that content blocked. And then lastly, you can just manually block it yourself. If there's a site that you don't trust to have tracking you, you can put in this do not call list, if you will, and Internet Explorer will no longer retrieve content from that site. So that was a quick roadshow of the features. Blew through it way faster than normal. Normally, this is a 2-hour talk. But the other thing I wanted to talk about very briefly before Q&A is what does the future look like? What does the browser future look like? We've done IE8. We're not done yet. What's coming next? Turns out the future is kind of scary. And the reason the future is scary is because of the incentives in play in the world right now. So I was talking earlier, that cool attack where you go and you clickjack someone and now you've got access to their microphone and camera. It's awesome. Why does it work? Well, it works because Flash provides access to the microphone and camera. Why does Flash provide access to the microphone and camera? Because it can, because HTML can't. How do you sell Flash? The product. You make it do things HTML can't, right? If you could only do things you could do in HTML and Flash, why would anyone ever use Flash? The whole point of these plugins is to do things the browser can't, because it makes the browser more powerful. The problem is, there's often cases where the browser can't do something because it's either a huge attack surface or it can't be done safely. Now, I know guys on these add-on teams, and they're super smart guys, and I like the stuff they're doing, but they're adding significant attack surface to the browser. Well, the problem is it's all competitive. So you got Flash out there. They've added a bunch of attack surface to the browser. Any other framework that wants to compete with Flash has to offer the same capabilities. Because if they don't, no one will use it. Just get Flash. It works. Standards guys have a problem with this. They don't like Flash. They don't like Silverlight. They don't like proprietary languages. They say everything should be in standards-based web platform. And they go out to web designers and they say, do everything standards-based. And they say, well, like to, but Flash does some stuff you can't. The HTML guys say, oh, what is it? We'll add it. HTML5 has a lot of really dangerous proposals. Socket access, rich mashup capabilities going cross-domain. There's a ton of things in HTML5 that are super scary. And that's fine. HTML5 is basically becoming a spec for an operating system rather than an HTML spec. But we have to be really careful that we understand how all of these different pieces come together. Because, visited links, the attack for clickjacking, all of these things have been around forever, and it's just the interaction of essentially introducing a bad guy into a capability system where the capabilities interact in surprising ways, where you get these dangerous, dangerous architectures. This is right now how I feel about some of the standards work. It's great, but it's very precarious, because if any one thing fails, everything falls over. Right now, HTML is totally safe against attacks against your microphone and your webcam because HTML can't reach them. As soon as it can, it becomes far more interesting. Problem, so you got to be secure by design, you got to be secure by default, you got to be secure in deployment. Design problems suck really bad. The reason design problems suck really bad is because often you can't fix them. Clickjacking is going to be extremely hard for the browsers to fix because the web is kind of meant to work that way. So that's going to be a real problem. So we have to be very careful that we just don't spackle over design problems. We consider them very early in the development cycle. So we've got 4 minutes left for questions. Hopefully someone has questions. Anyone? If any of the new people walking into the room have questions, they can ask. Yes?
So you're implementing a lot of sort of defense for the end users, especially with your anti-cross-site scripting technology, which is very good for the end users.
Yes.
However, do you feel that this will have an impact on developers? So if I was a developer, I would say, well, why do I care about cross-site scripting? I'll write my code, I'll just spat it out because the browser will protect me. Don't you think you're dumbing down developers?
Are we dumbing down developers? This actually comes up. They say, hey, Microsoft has an anti-cross-site scripting filter. Are they dumbing down developers? I wish. The reality is that, well, there's a separate argument as to whether or not certain classes of developers could be dumbed down. But there's a bigger problem with this notion that you can easily poke a hole in the logic of, we don't need to fix XSS bugs. And that easy hole to fix is basically Internet Explorer 8 right now has, I think it's something like 0.5% of browser market share. When we launch Internet Explorer 8, it might have 1% of browser market share immediately. Internet Explorer 6 is still the second most popular browser in the world.
Okay,
so the reality is,
this is the trend. So you're saying 8, you're doing this. 9, you're going to have even more layers of protection. By 10,
sure.
Developers, then there's no need to actually write security.
I would absolutely love it if in the browser, we could make the browser so secure that there's nothing a web developer could write that would be insecure. I would love that. My customers would love that. IT would love that. Because I would say, install IE10, and the web dev can do whatever he wants, and it will be perfectly secure. It's never, ever going to happen, but I would retire a very happy person if that would be the case. And so, yes, and it's important. The other thing to keep in mind is, back 50 slides ago, talking about balance. One of the key things that we have to balance is compat and security. If we break anything that needs to work by default, people will not upgrade. The primary way to get around this problem without throwing yet another dialog box in the user's face is putting it in the developer's control. And so earlier, Jeremiah mentioned the content restrictions proposals that are out there. We think content restrictions are cool. The reason that they're cool is because the web developer is in control. The end user doesn't make a security decision. The web developer says, hey, here's how my page works. Here's the JavaScript that I use. Here are the capabilities I want. And if you see any request for anything else, just fail it immediately. So that requires developers to have a deeper understanding. And we are outreaching to developers and saying, hey, we've got this new static HTML stuff. We've got this new JSON stuff. And usually the pitch is more than security. The JSON stuff is somewhere between 5 and 50 times faster than what people are doing today. So you know what? If you don't do it for security, do it for performance. And so engaging developers in these conversations is absolutely critical to the IE team. But I'm not worried too much about dumbing down developers because there's so many different attacks. There's so many different things for them to keep track of. And we've been very, very clear. You've just got to make these things work. And you've got to keep your users secure because not everybody's going to be running the most secure version of the browser. And you need defense in depth. You need to provide defense in depth because there's no mitigation in the world that's perfect. And so if you've got this attack surface, see if you can remove it. If you can't remove it, what can you put on top to protect the user? Last question. Yes? Can you come up? I can't hear you, unfortunately.
Very quickly, anything about proxies and reverse proxies with IE8?
Anything about proxies and reverse proxies?
Yeah, I mean,
so,
would there be any impact on current development?
Nothing has changed in terms of our proxy handling, so probably not.
Probably not at all?
Nothing has changed in proxy handling, so we should probably just take this offline and you can ask. If anyone else has questions, I'll be around here today and tomorrow. Thanks a bunch.